Hello, respected panel. This is Talha presenting the paper titled Android-based emotion detection using convolutional neural networks. The conducted study holds the purpose of studying performance of CNN and RNN over image datasets. For this purpose, facial expressions have been predicted using CNN and RNN, and the results are compared to evaluate which model performs better. The application where the model have been deployed is a music player, which suggests music based on user emotions, mainly termed as mood. The model trained can be used for multiple other purposes, especially in recommendation systems where news, food, etc. can be recommended based on the emotions of the user. The dataset that has been used for training and testing the respective models is from Kaggle, namely FER 2013 facial expression dataset, which has 35,000 plus images of different people of 7 different emotions. The dataset is pre-processed, meaning the images are grayscale of 48 by 48 size and labels from 0 to 6 for angry, disgust, fear, happy, sad, surprise, neutral have been assigned respectively. Coming to the background and related work, when we talk about sentiment analysis, researchers previously have worked with text being classified as positive, negative, or neutral. Different topics, identification algorithms have been discovered and used. For the past decade, this sentiment analysis has gained popularity, where data has increased in the dimension of images, videos, audios. Recently, object identification is used where an object like car, motorbike can be detected using deep learning techniques. Just like that, emotions from the image of a human being can be detected using deep learning techniques, and many researchers have already worked in this area. Early studies shows that to detect emotion, you also need to be aware of the pitch of the voice in order to detect human emotion. The study gathered 3 different elements from the participants: audio information, video information, both audio and video. The radical basis functions networks and the optical flow were used to categorize facial expressions. Microsoft with its cloud computing services provides API that have same functions as they have the required computational power. Example of that is the Face API by Microsoft. This uses the cloud computation. The user uploads its image and the model on the server detects the emotion and returns the confidence on the highest emotion whichever is calculated. Coming to our work, CNN has been a success up till now when used with images. Thus, for the proposed study, CNN and RNN has been used in comparison for evaluating the results. Here is the general flow of the study where data is first pre-processed using libraries like NumPy and Panda. The training and test sets are divided. CNN and RNN models, which are explained later, are trained using the datasets. Both the models are evaluated and compared for the accuracy achieved. CNN are designed with a quality of self-optimization through learning. Each neuron receives an input and performs a function. The entire network, when works with an image, it learns landmarks from the image and assigns a weight. The architecture of CNN. The model constructed for emotion detection using this type of network comprises of 4 convolutional layers, 2 fully connected and 4 max pooling layers. Convolutional layers use rectified linear units as activation functions, whereas final fully connected layers use sigmoid for getting probabilities of 7 emotion classes, where the one with higher probability is the class predicted. Coming to recurrent neural networks, for this method, convolutional long short-term memory neural net is used and is a hybrid of convolutional and recurrent neural networks. Convolutional neural networks take into account previous training examples, same as the time delay neural network for context. The neural network is given images with no direct relations with each other, with the pattern differences between previous images and their labels. The RNN architecture contains three convolutional layers. All the convolutional layers contains 10 filters with a kernel size 4 by 4 and time delay of 1 second. The activation function used is sigmoid for each layer. Moving towards the result of the study, the accuracy achieved using CNN is 65% on the test set. The confusion matrix with precision and recall are shown in the figure. Where it is seen, the most correctly identified class is happy, and neutral class is mostly mistaken with sad. The improved dataset can improve the results of CNN for the emotion classification purpose. The accuracy attained using RNN is 41%, which is very low as compared to the accuracy achieved using CNN. Also, the confusion matrix shows that the model is making much or wrong predictions and mostly predicting random where happy is most correctly predicted class. Coming to the conclusion of the study shows that CNN has outperformed RNN with the facial expression dataset. The study paves ways for more research in the area where various other types of neural networks can be used for emotion detection. The few limitations or hindrances that were faced during the study includes the dataset was not of the ideal number and of an ideal classification. The class imbalance problems affects the accuracy of both the models, where images for happy class outnumbered other classes. Thank you so much. This was Hafeez. Goodbye.